So we're going to do a hypothesis test about whether an average speed of a dog is less than or equal to 30 miles an hour, and the alternative being greater than 30. Now, the goal of this video is to talk about what is a p-value, what's the definition, what does it really mean, and the answer is it means exactly what we practiced all last chapter, those probabilities for a mean. So if we're going to do the definition of a p-value, there's three pieces to it. Number one says under the null hypothesis, assuming the null hypothesis is true. In other words, when I draw my picture, I'm going to draw it over whatever the null hypothesis said it would equal. Here it says that it would equal 30, so 30 is what goes here. The second part is, what's the probability of the statistic? So let's assume our statistic was 32 miles an hour, and so we're going to say, what's the probability of 32? But if we said, what's the probability of exactly 32? There's no area there. We'd have a probability of 0. It needs to say in what direction. And that's why the third step is probability of that or more extreme. Now, what more extreme means depends on this alternative. So over here, if our alternative says greater, then more extreme means what's the probability of that and greater. The less than means you would want the area that is the statistic or less. The hard part is when it's not equals, because that means you want the statistic or further away from me. So in our example, the way we have it right now, our alternative says greater than 30. So our p-value is going to be, what's the probability of 32 or more? Here, with this alternative, our p-value with a z-score of 2 would be 0.02275. So when I say the p-value is 0.022, what I'm trying to say is, if the mean really was 30, then the probability of getting an average of 32 or more is 0.02275. Let's change our alternative like this. Now, we want the area to the left. So instead of saying, what's the probability of getting 32 or more, I'm going to say, what's the probability of getting 32 or less? Which means I need to flip my side here, and there's my p-value now, 0.97725. My p-value completely changed because the question I was asking completely changed. I want to know, is the average less than 30? And my data says, whoa, no way! It's so not less than 30, it's possibly greater than 30. And your p-value is going to be huge to say, look, if the average is 30 or more, then this kind of data would be very likely. So, do we have evidence to support that the average is less than 30? No. The evidence is pointing towards the null hypothesis, and so we get a huge p-value. Let's try the hard scenario. Test whether the mu is equals 30 or not equals 30. So our question now is, could mu be far away from 30 and in either direction? I don't know if it's too far up or too far down, but both directions matter. Now, just by luck, we got on the high end. But the null hypothesis says, come on, if you redid this study, you'd probably end up on the low end or somewhere that far away. So for the p-value, we don't just want to say, what's the probability of being even further on the high end? We want to say also, what's the probability of being that far out on the low end? In other words, the probability of being that far away from 30 in either direction. Now the applet doesn't do a two-tailed area like that, and it's partly on purpose, partly because I think it would be confusing. So what we're going to do is we're going to say, I need this tail, and I know I have that much as the same area on the flip side. So this much area is 0.02275. I know this is going to be the same area, 0.02275. And now my p-value is going to be a combination of both of those, which is 0.0455. Here's some very common questions students ask. How do I know when I'm supposed to be doubling my p-value? The answer is, if it's a not equals, then you need to find the small tail and double that to get your p-value. What does the p-value mean? Well, if the null hypothesis was true, we would see this kind of data only 2% of the time. Well, we set our cutoff right here to be 0.05. So this happens more rare than what we call rare, which is our alpha of 0.05. So something is weird, something's wrong. Our data shouldn't have happened. It was very unlikely. We're going to declare the null must be wrong. Now, in this case, with the null hypothesis, the probability of getting data this high or something lower than that, 97% chance, which is a lot of support in favor of the null. So a high probability here, 97% chance data, it looks like our null hypothesis was doing fine if this was how we set up our null. Here, what's the chance of getting data this far away from the null or more? Well, there's only a 4% chance. Still less than our 5%. So this data was unlikely according to the null hypothesis, which makes us think maybe the null hypothesis was wrong. Calculating the p-value is the same math you've been doing before. The only thing we're doing now is using that in interpretation to come to a conclusion. Your p-value is evidence supporting the null. A lot of evidence to support the null, not a lot of evidence to support the null. Based on the p-value, we can decide should we reject or fail to reject our null hypothesis and make conclusions.